You hit publish, and somewhere a system has a fraction of a second to decide if you're fine or a problem. That system is the content moderation pipeline. Wave it through, block it, or pull a human in. Any wrong call burns trust.
And at platform scale, it makes that call millions of times a minute on content it has never seen. Miss real harm? The system failed. Remove a legitimate post unfairly? It failed a different person.
So the real question is not whether a model can spot a bad post. It is what the system does in the half second when the model shrugs. That is the whole episode.
Yeah, we will build that machinery piece by piece. The fast lane, the careful lane, and the way back for when the system gets it wrong. That sets up the whole map.
Now, here is the finished map up front because it is easier to argue with a picture. Ingestion creates a case. Policy decides what must be checked. Repeat material matching remembers confirmed abuse. Model scoring estimates risk, and thresholds route each item. Allow, block, reduce reach, or human review.
And it is not the magical AI bouncer people picture. It is an airport security line with different lanes.
Complete with somebody always beeping for no reason. Severe, obvious cases move one way. Routine, safe cases move another. The uncertain middle waits for a human.
And the guy who forgot a water bottle in his bag is not dangerous. He is just slow. That is your false positive. And he needs a way to appeal before his flight leaves.
So the map is really a promise. Act fast when risk is clear, slow down when judgment is required, and keep the reason behind every call.
So the functional requirements start with detection. Text, images, audio, video, metadata, reports, and account context, all judged against a policy set that will not sit still.
That one phrase is, quietly the whole problem, right?
It is. For example, new rules arrive, old ones get clarified, legal lines differ by country. You can watch it happen in the platform transparency reports linked in the description, and the product still asks one question. Can this content be visible right now?
So the verbs matter too. Approve, take down, throttle reach, age gate, ask for edits, send to review, and let people appeal.
Yes. Detection alone is a demo. Detection plus a decision record, plus a way to undo the decision, that is a moderation system. The record is what makes policy enforceable.
Now the non-functional requirements, the uncomfortable ones. Low latency for uploads, high throughput for feeds, durable decisions, privacy for reviewer context, fairness across queues, and the kind of thing nobody budgets for, auditability for every call.
Wait, fairness for whose side?
Exactly. Not just fairness to users, fairness inside the workflow. If appeals sit behind routine reviews, a wrongly removed creator waits days. If severe reports sit behind ordinary uploads, dangerous material stays up. Queue ordering is a product decision disguised as back-end plumbing.
Oh, wow. So moderation latency is not one number. It depends on the risk of being late.
Yes, a harmless cooking clip can wait for a post-publish scan. A credible severe risk report cannot. The result is latency targets matched to risk, route by route.
So the first fork in the road, check before publish or publish and keep scanning. Pre-publish checks block content before anyone sees it. Post-publish checks let it go live and watch after.
Blocking first sounds safer, but I can already hear the problem. Every upload now waits on the moderation path.
That is the trade-off. An SRE would put it bluntly, your upload P99 just became your slowest model's P99. For example, a creator uploads a video. Every image, caption, audio track, and frame scores before publish, and their launch sits waiting behind your slowest model.
So in practice, fast, cheap checks guard the door and deeper scans keep watching after release?
Usually the architecture mixes both, sort of by necessity. The decision stops being block or allow and becomes a release risk budget.
Once the fork is chosen, Ingestion opens the case file. Content arrives with media type, uploader, region, language hints, visibility target, report source, and the surface it will appear on.
Meaning where it is going to show up?
For example, a direct message, a profile photo, a live stream, and a search result can carry different risk budgets and different rules. Same bytes, different surface.
Yeah, that's the trap. A case record that only says image has already thrown away the urgency and the risk.
So the record has to be specific before the model ever sees the blob. Get it right, and every later layer inherits context for free. A sloppy case file makes them all dumber.
Then, before any expensive inference, run the cheap memory. The repeat material layer keeps hashes and fingerprints from items reviewers already confirmed.
And this is where people picture a normal file hash, right? Same file in, same hash out.
Sure, for exact copies, but recompress the image, crop 1 pixel, add a border, and a regular hash is a stranger. So platforms use perceptual fingerprints for near copies, the trick behind known bad matchers like photo DNA.
So one cropped pixel dodges a plain hash entirely. No wonder the memory path exists. Never make a model rediscover a violation a human already confirmed.
Right. It does not replace the rest of the pipeline, but when a prior review settled the case, it is the fastest exit. Skip the old work, remember why.
Now the unresolved cases reach the model layer. Text models read language, image models score frames, audio gets transcribed and scored, video systems sample frames, scenes, captions, and metadata.
But the output is a score, not a verdict.
So what stops a team from just trusting the score anyway?
Nothing but discipline. I've seen teams wire the score straight to removal because the demo looked clean. It works until the first viral wrongful takedown, and then nobody trusts the system again.
And that is honestly the whole point of this layer. The model emits category, confidence, severity, evidence for routing, and policy still has to wrap it. The number where policy draws that line is doing far more work than it looks.
So a score is just a number until thresholds turn it into a route. High confidence harmful, block automatically. Clearly low risk, approve. The middle goes to humans.
Here's where it gets interesting. That middle band is the budget problem. Every unclear item becomes queue time, reviewer time, and a user waiting.
Yep. The review zone works like a pressure valve. Squeeze it narrow, and the model makes too many final calls. Open it wide, and reviewers drown.
Wow. So the threshold is really a staffing dial, not a math constant. Move it a few points, and you just hired or fired a review team.
And it doubles as a budget request. The threshold tells the team in advance the staffing cost of the policy.
Once cases need humanized, priority queues decide who waits. Severity, virality, reporter trust, content reach, account history, appeal status, and legal deadlines can all reorder the line.
Let me take the reviewer manager side. They would say, if everything is urgent, my team just gets a burning pile with labels on it.
Fair pushback. Labels do not create capacity. Priority has to create service levels, not panic. For example, severe high-reach content gets minutes. Appeals get hours, and routine backlog scans can wait days.
I love that. It is an OS scheduler. Background work can wait, but the cursor cannot.
Yes, different promises, different clocks. Every queue ends up wearing a clock tied to its promise.
So queues only sort the work. The architecture still has to include human review explicitly. Reviewers need assignment, context, policy guidance, decision capture, escalation, quality sampling, and fatigue protection.
That list is easy to under-design because it sounds like operations.
And it is, a system property. Rotate severe categories, cap exposure, sample decisions for consistency. No single person should be the entire policy engine for hours.
I once saw a review queue look efficient while accuracy quietly fell apart because the hardest category had the fewest trained reviewers.
Man, we have all trusted a green dashboard that was quietly wrong. Throughput was green, but the decision quality was red.
An accuracy nightmare wearing a healthy dashboard. The queue was hiding the incident.
From the review desk, appeals need a compact case record. Policy, scores, reviewer context, original decision, and outcome.
Because we removed it because the system said so is not an appeal process.
Right. For example, the appeal path gets its own queue, its own service level, and usually a different reviewer pool, so the same mistake is not rubber-stamped twice.
See, that's the part people skip. A reversal is evidence. It shows exactly where a decision needs another look.
So the appeal queue is basically a second adversarial read of your own decisions?
Exactly that. And if reversals vanish into a support ticket, the system never learns where it hurts people. Fed back properly, one reversal improves safety, product trust, and training data at the same time. Receipts, not rumors.
Then the feedback path turns operations into model and policy changes. Reviewed decisions become labels, appeals expose false positives, reports expose misses, sampling audits measure consistency.
Can the system train on its own mistakes there?
This is the scary version of automation. Yes, and it is a real danger. Imagine every auto removal becoming a trusted label. The model starts reinforcing its own bias. Human-reviewed outcomes need stronger weight than automated guesses.
So a label needs to carry its source, the reviewer, the policy version, and the reversal outcome.
Otherwise, the label history is just timestamps with confidence scores.
Exactly. Provenance first, training data second.
Now, the attackers get a vote. They re-upload, crop, add noise, split text across frames, use code words, coordinate reports, or flood the review system to slow it down.
So the adversary is not just posting content. They are probing the pipeline.
Yeah, which is why rate limits on reports, anomaly detection on coordinated behavior, near duplicate matching, account reputation, and, review queue circuit breakers live in the same architecture.
Hold on. So a report flood is itself a moderation event, not just noise around the system.
Yes, put a breaker on reports before they bury the reviewers. Imagine a sudden, low-trust, highly coordinated wave. Degrade it, sample it, or reroute it instead of letting it bury urgent, real cases.
Yep, defending the workflow is protecting users. Attackers pressure test the edges first.
Finally, the metrics, speed, quality, and harm each need their own view. Precision, recall, time to action, appeal overturns, and severe case escapes.
The average can lie, right?
Completely. One healthy global number can hide a category, a language, or a reviewer pool in real pain.
Right, so slice it by category, surface, and queue before you trust it.
So which slice usually breaks first?
Usually the one nobody staffed. Take a newly launched language where the reviewer pool is thinnest. That gives operators the dashboard worth watching first.
And now? Whoa, the map from the start reads differently. Queues set service levels, review captures decisions, appeals reopen cases.
Repeat detection remembers prior decisions. Abuse defenses watch the edges. Metrics keep speed and quality honest, separately.
The summary is short. Certainty moves fast, uncertainty gets judgment, and mistakes get a way back.
Fast where it can be, careful where it has to be. The map roots uncertainty instead of pretending it vanished.
From that full map, a moderation pipeline is not a model endpoint with a delete button. It is a system built around uncertainty.
The way I remember it is accountability. Fast calls still need receipts, and corrections have to make the next call less blind.
Yeah, the model can be wrong, so the architecture needs a path to correct itself.
Yes, that humility is the design. Next video, we move from uncertain judgment to multi-region databases, conflicting rights, latency, consensus, and the cost of letting many regions accept changes at once.
Sure, I like that setup. Different problem, same pressure.
Yeah. Thanks for listening to Learning Podcasts.